Okay, now we're on to question 7. So these two expressions have the same denominator, so they can be put into one. And in the numerator, we're going to get 3r plus 1. And here's where you have to be really careful because it's minus all of that. So the negative sign has to be applied to every term. So minus r minus 9. So I'm going to have 3r minus r is 2r. Then I'm going to have 1 minus 9 is minus 8. And then in the numerator, that will factor. They both have a 2 that can be factored out. And now since I have a product in the numerator and denominator, I can cancel out this r minus 4. And so my answer is going to be 2. Now, if you wrongly chose this one, you did not apply that negative sign to the 9. And you got 1 plus 9, which is where you got that 10, and that's not correct. So the answer is D. The answer is D. Okay, let's keep going. Find the product. Okay. So when you have a product, you just multiply the tops and the bottoms. Let's factor. I can factor out a 2 there. Then k squared minus 16 factors to k plus 4 times k minus 4. And then we have k minus 7. Now I have a product in the numerator, a product in the denominator. So I can cancel the k minus 7s, and I can cancel these k plus 4s. So after cancellation, I'm going to be left with 2 over k minus 4. Okay, so the answer is going to be C. Okay, continue. All right, now let's identify the domain. Well, we have a rational expression here, and the denominator is not allowed to be 0. So that's not allowed to be 0. So I'll write it up here. So where do you get in trouble? You get in trouble if x is negative 5 and if x is negative 6. So those are not allowed. All right, and then you can see all the selections here are in interval form. So if negative 5 and negative 6 are not allowed, then on the number line, I'm not allowed to include them. So I'm hollowing those out. It can be anything except negative 6 and negative 5. So anything except negative 6 and negative 5. So this is what it looks like on the number line. Now, if I read the number line off from left to right, we're going to start at negative infinity, come up to but not include negative 6. Then we got to jump over that gap at negative 6. Want everything between negative 6 and negative 5. Jump over this gap at negative 5. And then everything past that. Okay. And that is matching up with D. Okay. Let's continue. Find the y-intercept. Okay. If we're going to find the y-intercept, then it's going to be f evaluated at 0. So everywhere there's an x, you replace it with 0. So you can see every term with an x in it becomes 0. And so you're just left with the constant terms. So that's the y-intercept. Now, as a point, its coordinates are 0, 5/7. Okay, so that's the one that we want. Okay. All right, continuing. Okay, now you get a hole in the graph wherever there is cancellation. So a hole is created when there's cancellation. And the number of cancellations give you the number of holes. All right, so if I look at A, nothing cancels. If I look at B, nothing cancels. If I look at C, nothing cancels. But when I come down here to D, I have a product in the numerator, a product in the denominator. The x minus 8 terms cancel. So the x minus 8 terms cancel. And there's no other cancellation. So D has one hole. Now, how many vertical asymptotes? Vertical asymptotes are found at the zeros of the denominator after any cancellation. So if we look at D, after cancellation, the denominator is x minus 2 times x plus 5. And what are the zeros of that? What makes it equal to 0? Well, if x is 2 and if x is negative 5. So I will have two vertical asymptotes. They will be the vertical lines with equations x equals 2 and x equals negative 5. So D has one hole and it has two vertical asymptotes. So the answer is going to be D. Okay, let's keep going. Find the vertical asymptotes of the rational function. Okay. I'm going to need to factor this. Now, the numerator does not factor anymore, but the denominator does. Two numbers that multiply to give me negative 24, but at the same time add up to give me positive 10. That's going to be positive 12 and negative 2. If you multiply those, you get negative 24, and then positive 12 plus negative 2 gives me positive 10. So the two numbers I need are positive 12 and negative 2. Okay, now vertical asymptotes are found at the zeros of the denominator after any cancellation. There is no cancellation here. Now, what will make the denominator equal to 0? Well, if x is negative 12 or if x is equal to 2. So there are two vertical asymptotes. Their equations are the vertical line with equation x equals negative 12 and the vertical line with equation x equals 2. All right, it's going to be that one there. Okay. All right, find the equation of the horizontal asymptote. Let me make this a little bit bigger. Now, with the horizontal asymptote, there were three cases you had to know. So for a horizontal asymptote, what is the degree of the numerator? So the degree of the numerator is 2. And the degree of the denominator is 3. So the degree of the numerator is smaller than the degree of the denominator. And if that's the case, there is a horizontal asymptote, and it's the x-axis. And the x-axis has equation y equals 0. Okay, so that one there. Okay. All right. Find the x-intercept values. Now, x-intercepts are found at the zeros of the numerator after any cancellation. We can see here there is no cancellation, nothing cancels. Now, what will make the numerator equal to 0 if x is negative 2 and if x is negative 7? So there will be two x-intercepts. As points, they're like that, but their values are going to be negative 2 and negative 7. Okay, and so the answer is going to be A. Okay, let's continue. All right, we want an equation of an oblique asymptote. There's a couple of ways we could do this. You could do this by long division, or you could use synthetic division. If I do this by long division, then x times what equals x squared? Well, x times x. So I take this and multiply it by everything here. X times x is x squared, and x times 7 is 7x. And then I subtract this line. So x squared minus x squared, they cancel. Then I have 5x minus 7x. And then I carry this one down. Now, the next thing to ask yourself is x times what equals negative 2x? Well, x times negative 2 equals negative 2x. And then I take the negative 2 and multiply it by everything there. Negative 2 times x is negative 2x. And negative 2 times 7 is negative 14. And then I subtract this line. Negative 2x plus 2x, they cancel. And then I'm going to have 3 minus negative 14, 3 plus 14, which is 17. And this is a constant. See, I wasn't done here because this had degree 1, and you're not done until you get degree smaller than your dividend. So we're done. That's our remainder. So the oblique asymptote, the slant asymptote, has equation y equals and x minus 2. So I want to type that in without any spaces. Okay, now I could have used synthetic division. Synthetic division, the denominator just needs to be x minus a number. So x minus the number in the box. So I'm just setting it up for synthetic division. And so the quotient, these are the coefficients of the quotients. Where the line is, there's your constant and there's your coefficient for x. So the oblique asymptote is y equals the quotient. So y equals 1 times x, which is x, minus 2. Okay, and you get the same answer. So either way would have done that. Okay, let's keep going. Okay, here I'm going to have to do long division. So we're going to have 8x cubed plus 5x squared. There's no x term, so leave a gap. And I want that divided by x squared plus 2x minus 1. So I'm going to look at these two numbers. What do you have to multiply x by to get 8x cubed? And I'm going to need to multiply that by 8x. So now I'm going to take this and multiply it by everything. 8x times x squared. 8x times 2x, and 8x times negative 1. Then I'm going to subtract every term. So I'm going to have 8x cubed minus 8x cubed, 5x squared minus 16x squared, and 0 minus 0 times x minus negative 8, and then minus 9. So now I'm going to look at x squared and negative 11x squared. What do I need to multiply x squared by to get negative 11x squared? Well, negative 11. Then I'm going to multiply everything here by negative 11. And negative 11 times 2x, and negative 11 times negative 1. And then I subtract everything here. Negative 11x squared plus 11x squared, they go away. 8x plus 22x, and negative 9 minus 1. Now this has degree 1, this has degree 2, so we're done. This is our remainder. This is our quotient, so my answer is going to be y equals 8x minus 11. And that matches up with D. So the answer is going to be D. Okay. All right, let's keep going. All right, does this have any holes? That's the first thing. You get a hole if you get a cancellation. So you have x minus 3 and x minus 3. There's one cancellation. So, and we also have x plus 1 and x plus 1. So we have two cancellations, and that means that there are two holes. Okay, so looking from the selections there, I don't really need to go any further, but let's get the rest of this. Vertical asymptotes, they're found at zeros of the denominator after cancellation. Everything in the denominator has canceled, so there will be no vertical asymptotes. And then x-intercepts are found at zeros of the numerator after cancellation. So I'm going to have one x-intercept. What will make that 0 if x is negative 8? So that's my x-intercept, and I only have one. So my answer is C. Okay. And let's continue. All right, we're going to need to factor the numerator. So two numbers whose product is negative 30. And whose sum is 7. Okay. I could have positive 10 and negative 3. Their product is negative 30, and then positive 10 plus negative 3 is 7. Okay, so instead of 7x, I'm going to replace that with 10x minus 3x, okay, because my two numbers were 10 and negative 3. And then I'm going to pair these up. Let's see what factors there, and I'm going to see what factors there. Okay. So I can factor out a 2 and an x. And with these, I can factor out a negative 3. And that's a plus, because negative 15 divided by negative 3 is positive 5. And so what goes in here is going to be 2x minus 3. So I come back up to the top here, and I can factor this as 2x minus 3 times x plus 5. Now, x squared minus 25 factors as x minus 5 times x plus 5. So I have cancellation. There's one cancellation, there's one hole in the graph. And where does the hole in the graph happen? Well, I can only make that cancellation if x was not equal to negative 5. So my refined graph is, and x is not equal to negative 5. Now where's the hole? The hole is going to be at x equals negative 5. Now what is the y-coordinate of the hole? You plug negative 5 into your canceled function. That's going to be negative 10 minus 3 all over negative 10. That's going to be negative 13 in the numerator and negative 10 in the denominator. The negative signs cancel. That's going to be 13 tenths. And that's matching up with A. So our answer is going to be A. Okay. All right, let's find the hole in the graph for this. Let's see. The top will factor as x plus 5 times x minus 1. And what about this? I want two numbers whose product is 2 times 3 and whose sum is negative 5. So the two numbers are going to be negative 2 and negative 3. Negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. So instead of that, I'm going to write that. And then I'm going to factor these pair and factor that pair. So a 2x comes out of the first pair. And a negative 3. So if I divide that term by negative 3, I'm just left with x. And if I divide that by negative 3, I'm left with minus 1. Then what goes in here? 2x minus 3. So I can make this cancellation provided x is not equal to 1. So my refined function is x plus 5 over 2x minus 3 if x is not equal to 1. So where is the hole? The hole happens at where we had the cancellation. So the hole is going to be at x-coordinate 1 and y-coordinate when we plug in 1 for our refined function. One plus 5 is 6, and 2 minus 3 is negative 1. 6 divided by negative 1 is just negative 6. So we get a hole at 1 comma negative 6.